We have a real number system that we work with in math, and all the numbers we've been talking about so far this year have been in the real number system. So today we're going to focus on classifying a number and determining if it's irrational or irrational. So copy down your target, and then you have a box on the front of your page, but you don't have all the stuff in it that I have. So I want you to fill this out with me. Go ahead and copy down your target first, and then if you need to press play, you can do it as I talk. So the smallest category we have that we're going to start with is these natural numbers. And the natural numbers, I always remember this by what do you naturally start counting with? Naturally at birth, whenever you get old enough, to start talking and you start counting, you start with 1. 1, 2, 3, 4, 5, and you go on. So those are the natural numbers. That does go on forever. We can use the letter N to abbreviate natural. After the natural numbers, the next biggest category would be the whole numbers. And whole numbers actually only adds one number. So it's all the natural numbers plus one number. So 1, 2, 3, 4, those are actually within this natural realm, but they are also whole numbers, and all it adds is 0. So the whole number family is 0, and then all the natural numbers. We abbreviate whole in algebra using the W letter. Make sure you put in some examples of the numbers in each of these circles. The next category then is integers. In integers, we actually abbreviate with Z. I actually don't know why we abbreviated with Z. That's something that you could look up on your own. But we use Z to abbreviate in algebra, okay? It's the integer family. And the integers are all the natural numbers, all the whole numbers, and then all of their opposites. So it's all the whole numbers and their opposites. So 0 would be an integer. It would also be a whole number. It would not be a natural number, excuse me. 2 would be an integer, a whole number, and a natural number. Then all of those categories fit into this family of rational numbers. And rational numbers are numbers that terminate or repeat. So all the integers are rational numbers. What else do we add to that family? Fractions, 1/2. Decimals, maybe 2.5. But they have to terminate or repeat. So 1 or 4/3 would be a rational number. It goes on forever. It's 1.333333, on and on and on. But these are all rational numbers. You could also put in a square root of a number that you could find, such as the square root of a decimal like 1.44. If you use your calculator to find that, you'll see that that's 1 2/10. The square root of 1 44/100 is 1 2/10. So that is a rational number. It's a decimal that terminates or repeats, or it's a number that can be written as a fraction. Next to this rational family, because there's no overlap, we have the irrational family. Irrational numbers are numbers that do not terminate and do not repeat. Pi is an irrational number. And any square root of a non-perfect square. So the square root of 3, the square root of 18, the square root of 26. Those would all be numbers that would be decimals that would go on forever and never repeat. So these are all the real numbers, okay? Everything is either rational or irrational. And within the rational world, we have these 3 worlds: integers, wholes, and natural. Something separate from that is imaginary numbers. And no, I'm not making this up. Over here, completely separate, we have imaginary numbers. Now, this is something you really could look up on your own to learn more about. But basically, it was something that a mathematician came up with so that they could continue to work on a problem when they got to a point they had to stop at. And they used the letter I to represent the square root of a negative number. So an imaginary number would be something like the square root of -4. When we did square roots the previous day, we tried to do the square root of a negative number, and we found that we couldn't do it. The square root of -25 isn't 5 or -5. It's just not a real number. So all of those negative square roots make up the imaginary family, or not real family. So hopefully that makes sense. If you need to pause the video to finish getting down the titles and the examples, go ahead and do that. Otherwise, we're ready to go on. So we're going to classify these numbers, okay? Write all the names that apply to each number. And you can look at your picture to help you. So for the square root of 5, you need to figure out where that fits in your diagram. The square root of 5 is a number. It is a decimal that goes on forever. And it's not -5, so it's definitely real. This would be a real number. Your question then, is it irrational or rational? Does it terminate or does it go on forever? Well, the square root of a number that's not a perfect square goes on forever. So it would be irrational. Is it an integer? Not if it's a decimal, not if it has something after the decimal point besides zeros. Is it a whole number? No. And is it a natural number? No. So that one we can only classify as real or irrational. The next one, -11 and 45/100ths. Well, we can see right away that it terminates or repeats, which means it must be rational. If it's a rational number that terminates, then we then have to ask ourselves if it's within that category. So is it a integer, a whole number, or a natural number? Any of those. This one's not any of those. It has a decimal, so it's definitely not an integer or a whole number. Oops, sorry, I'm not writing that. It's definitely not an integer, a whole number, or a natural number. The last thing we have to ask ourselves then is it real? Yeah, this is a real number. We can write it, we can use it in math, so it's rational and real. Now that third one, before you classify it, evaluate it, okay? If there's any simplifying you can do, you want to do that first. So let's actually take the square root of 16, because we can do that. The square root of 16 is 4. So these numbers are the same. All I did was simplify the square root of 16. Well, now I can simplify that. 4 divided by 2 is 2. So when you're classifying this first number, really you're just classifying this last number, because those are equal, right? So classify 2. Give it all the names that possibly apply to it. I like to start either on the inside or the outside and work my way around. So let's start at natural. Is this a natural number? Yeah. Okay, then go to the next category. Is it a whole number? Well, the whole numbers are all the natural numbers and zeros. So yeah, if it's a natural number, it is a whole number automatically. And if it's a whole number, is it an integer? Absolutely. And since it's an integer, what other category does it fall into? The rational. So this is like a Venn diagram that you use in English class. Except normally when you see a Venn diagram, you see it with like 2 circles and there's overlapping. So, you know, this might be students that play football and students who play an instrument. And there are some students that do both. Well, in this case, you have a circle within another circle. See, that natural family falls completely into the whole family. There's one number that is not natural but is whole, but all the natural numbers are automatically whole numbers, if that makes sense. So you're looking kind of at the nesting. I think of like those nesting dolls. The circles are nesting within each other. So we have natural, whole, integer, rational. The last word we need is real. It's in the real family. All right, for example 2, I just want you to state if the number is rational, irrational, or not real. So I want you to try example 2 on your own. Remember, simplify if possible. Pause it, put down one of each of those words, okay? Either rational, irrational, or not real. And then press play and let's see how you did on these 4. Okay, now that you've tried 2, A through D, A would be irrational. It is a number. We can find the square root of 17, but we would have to estimate it because it goes on forever, so it's an irrational number. 0 divided by 6, well, 0 divided by any number is 0, so 0 is a rational number. It terminates or repeats, whereas irrational numbers don't terminate and do not repeat. The square root of -4, I hope you caught this. Can you take the square root of a negative number? No, you cannot, so this is not a real number. You could also write imaginary. So you could also write imaginary, okay? You don't have to, but you do need to know that it is not real. And the last one, you can simplify that a little bit. We have two numbers in which we can take the square root. So you're allowed to do that. Do each part of that. The square root of 16 is 4, and the square root of 9 is 3. 4/3, is that irrational, rational, or not real? It's definitely not real because it doesn't have a square root with a negative. So it's either rational or irrational. Which is the one that can be written as a fraction? Because this is a fraction. Rational. So hopefully you got all 4 of those right. If not, go ahead and fix them up, and hopefully they make sense now. If you have questions, please see your teacher and ask. The last thing that we're going to talk about today then is cube roots. So we talked about square roots. You should be comfortable with some of the cube roots as well. The cube root of a number is the opposite of cubing, or to the 3rd power of a number. So when you see the cube root of 8, that's equal to a number, and the number that it's going to be equal to is the number that you would cube to get 8. So the cube root of 8 is a number that when you cube it, you would get back to this value of 8. So what times itself 3 times gives you 8? Well, I mean, is it 1 times 1 times 1? 1 times 1 times 1 is only 1. Is it 2 times 2 times 2? 2 times 2 is 4, and 4 times the last 2 is 8. So the cube root of 8 would be 2. 2 cubed is 8, so the cube root of 8 has the value of 2. Try A and B under example 3. You can try this on your own if you want, or you can stick with me if you want. The cube root of 125, so you're asking yourself, what is that value? What would I cube to get up to 125? And this one, what would I cube to get up to 64? I would keep going with this idea. What's 3 times 3 times 3? Well, 3 times 3 is 9. 9 times 3 is 27. What's 4 times 4 times 4? 4 times 4 is 16. 16 times 4 is 64. We have that 64 right down here. So the cube root of 64 is going to be whatever I cubed to get 64. 4 times itself 3 times gives me 64. So the cube root of 64 is 4. All right, so what do you think this 125 is going to be? Let's try the 5 times 5 times 5. 5 times 5 is 25, and 25 times 5 is 125. So the cube root of 125 is 5. It's that number that you multiplied by itself to get the inside. You're ready for your quick check.